Hi guys, I welcome you to my channel. Today I will solving this number of island problem. This problem basically is from new section of the DSA or Blind 75, that is called graph. So it's very simple question, or easy question if you understand. I had solved like long 1 year back and solving now. So and I solved in one go. So what's saying that we will be given an M cross and 2D binary grid and which represents 1 and 0, which represents a map of 1 and 0. 1 is basically land and 0 is water. Return the number of island. An island is surrounded by water formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So a island is land which is surrounded by water. So if there is no there is no water outside, let's see here. This one do not have some any in the row minus one column, 0 minus one row, right? But we assume that that is the water, okay? And I have to return that all possible, all the land, all island I have to return, right? Very simple question. You take the index first and we will go top, left, right and bottom, and we'll return the island count. Very simple question, simple DFS question. We have to do this is marked medium but simple DFS. So I'll write DFS. Let me pre-calculate some of the variables. Rows, calls and length of grid, comma length of grid of 0. Rows, calls, I got the rows and I got the calls, right? I'll create a map set visited, that is set. Why I am using that? So that once I visited one island, I should not visit again. That's why I have added that. And I will just count is equal to 0. I'll add count is equal to 0. I'll add my function here. So let me write first this DFS, and I have return count, right? Now let me write the function here for I in range of rows or j in range of calls, right? And if we will have DFS here, DFS that will take two variable I and j. And if if grid of ij is equal to this 0, sorry 1, and we are not visited, and I comma j not in visited. If this is true, I'll update my count and I'll call DFS I comma j. Okay, now we have DFS definition. We have already DFS here defined. Definition DFS, it will take two variable. I'll check this is out of bound or not. So if I less than 0 or I greater than equal to length or rows, or j get less than 0 or j greater than equal to calls, return. And we will return on this variable as well, or we'll check that, we'll try to check this thing. Or I'll try to check that if that character is not 0. If that is 0, then I'll not going to proceed further. So I'll check that grid of ij not equal to 0, and other thing I'll check, or that is not that particular grid of ij is not visited. So ij not in visited. If this all is case satisfy, I will just return. Otherwise what I will do here, I will update my visited of I comma j and I'll call the four direction top, left, right, bottom. So DFS of top I plus 1 comma j. So it is basically going downward. I minus 1 comma j, it is going upward. I comma j minus 1, it is going left, and this will go to right. This will go to right and it will mark everything as a visited. Okay, and for that, for the, like, consider this is the root. This is the, like, one is the root here. Let me draw. One is the root here. Okay, and we have to go all possible four directions. So consider this is the one. Okay, so you have to go, you'll go row minus 1, that is nothing is there, so we'll go row plus 1. So row plus 1 we have 1. Okay, we'll mark that visited. We will go row minus, sorry, call minus 1, nothing is there. Call plus 1, we have something, so we mark this two thing as a visited. Now we'll go for direction of this one. So we have one, this one, right? So we'll go left, nothing is there. Row minus 1, nothing is there, right? Because it was there but we have marked as visited, but we are returning it here. We will not visit if that is already visited, right? So we will not do that. Bottom, yeah, we have something in the bottom, and we have something in the bottom. Then right, we have something in the right. Okay, same, and we will mark bottom and right visited. Now I'll go to the bottom and try to check if nothing is there on the left, nothing is there on the bottom, nothing is there on the row minus 1, and there is something on the call plus 1, right? J plus 1, j plus 1, this last one. So I will just call that j plus 1 part here 1 and mark this as a visited. This is a visited. Now again I go left bottom. So again this is visited, this is not, this is not, this upper. We can go on the top, right, and we'll mark that visited. So see, this is how it works, and in one go, all the connected, all the adjacent one of from this one will be marked as visited. So next time when we are going to check, we will be having only those which is not visited, and so that we will get a unique island all the times. This is how I've written this code, and let me submit first, then I will do time complexity fixed time is going up. uh, what is the problem here? N is not defined. I and J, sorry. hmm? I've done something wrong here. We have rows, we have columns. Yeah, if I less than 0, I greater than equal to rows, j less than 0, j greater than equal to calls, or grid of I and j not equal to 0, and ij not visited. Okay, I will add this. Sorry for that, I will add this. It's okay. I'll go I plus 1, I minus 1, j minus 1, and j plus 1. Nothing worry, we are going first be any order does not matter, and I in range of j in range of column. If grid of I is equal to 1, and I of j not in visited, I will call this I of j. It's very simple question. I am failing here. I less than 0, I greater than equal to rows, j less than 0, j greater than equal to calls, and or grid of I is not Okay, sorry. If grid of I is equal to 0, then only I'll return. If not, then I'll why not? Now still 0. Grid of I and j is equal to 0, or I in visited. We have already visited. Sorry, I in visited. We have already visited it. Not visited. We have already visited it, and I will return it. Now it works. After this, we'll try to calculate time complexity. Yeah, I've submitted this. I have beat 39% of the Python developer. Let's calculate time complexity for this problem. So what we are doing, that for each index we are trying to go um, all the one, right? So for each I is equal to 1, we are going to all 1. So um, what can we say here? So we are going and loop all connected, and in worst case we will have m cross n. So time complexity will be this, m cross n. So for each one, 1 to the power m cross n, it is m cross n only, like 1 to the power not m cross n, that is m cross n. That is why I understand why I'm saying that. So consider that all the element is 1, all the element is 1. So for this one, we will be looping every index. Will go into every index. This DFS will go every index, and this will not. This index, this DFS will not go twice, right? It will go only one. So m cross n, right? M cross n will be time complexity, and we are visiting only once. So this is m cross n only. That's it, nothing else. Let me ask ChatGPT what is time complexity for this. ChatGPT, what is time complexity for this? What is TC for this? It's correct, na? Space complexity. Space, basically we are doing recursion, right? So that is O of m cross n only. Space is also same. Time is also same. Yeah, I was able to predict it. So yeah, it's very simple question. Number of islands, and very asked question as well. 23,000 people have liked this question. Yeah. Do we have any optimized one from this? Let me check. Do we have any optimized one? We can use DPFS, Union Find. We do not have to write a set. We can mark that it is visited, so space will be reduced, space complexity. But it's okay. So we got the point that code I have written, it is already optimized on, and the time complexity is over m cross n. So let's meet tomorrow. We'll solving another question of blinds. So blind 75, that is clone graph, and very interesting question. And how many people have liked this question? 10,000 people have liked this clone graph question. So let's see how this problem goes. Okay, thanks for watching. Bye bye.